out sigma prime by using, and C3 is this factor. It is given in the form of the tabular formula form, and I can take that value from the table and I can find out the value of sigma prime. That means sigma prime is equal to sigma bar divided by C3. That is what it means. Okay. So we can call it by some means this sigma, no, sorry, instead of C3 we can use it, you can call it as C2, not C3, we'll call it as C2. Okay, because C3 is used for something else. Similarly, instead of calculating so much this thing in this way, instead of calculating like this, then they started thinking whether the same thing can be calculated. That is what I left it in between, that range. They found out that you can find out the range of this one also. That means the range of this sample is the difference between highest and the lowest value in that sample. First sample, second sample, third sample, and fourth sample. That those range of values are R1, R2, R3, and R4. Because it is very easy. This is the smallest. Say for example, here X4 is the highest, X1 is the smallest, then the difference between that one, R1. Similarly, for next group like that. So then what is going to be R bar? R bar is equal to R1 plus R2 plus R3 plus R4 divided by 4 in this case. That will become R bar. Now, he has also established how this one is connected to. Like this one is connected to the sigma bar is connected to universal standard deviation. Similarly, he defined a factor or sigma. Again, D2 is the factor which will depend only on the subgroup size. That means how many samples I have taken to make one group. So this will become more easier because finding R or R bar is much easier than finding this. So I can directly find out sigma prime. Once I find out sigma prime, I can find out sigma x bar also instead of this. So in many ways, I can make use of that. Okay. But somehow for control charts for variables, we'll be using two charts in combination. One is X bar and R chart or X bar and sigma chart. Both things are to be used in conjunction to draw the meaningful information about the process which has got a measurable characteristics. Okay, I am going to stop today at this point of time. Tomorrow's class we'll start with this one and maybe with some numericals or again maybe some brief idea about the objectives and other things, because I have tried to give you the relationship between the various values. Okay, thank you.
So good afternoon. So in the last class we had discussed about the different phases of product life cycle management and how a product behaves in each product phase of the product life cycle management, and it also tells the people or the industry when to introduce a new product and when to withdraw the old product from the market depending upon in which phase the product is present, and also what is the sales and what is the profit margin the product is withdrawing from the market. And also we have discussed about something called as cannibalization. That means how to incorporate a change in technology in a product so that the new product is launched in the market irrespective of the old product in which phase it may be there. So that is called as cannibalization, and we have discussed different phases of cannibalization. So in today's class we will discuss something called as concurrent engineering. Something called as concurrent engineering. So in order to discuss this concurrent engineering, we will first try to know what is called as sequential engineering. We'll try to know what is called as the sequential engineering. So for that, So here, what I can see in the sequential engineering is that we know that during development of a product, it passes through different departments such as marketing, design, the planning, the manufacturing, the quality, the sales and services, and then again to the marketing. This all represent the different phases of a product through which it passes when it before releasing to the customers. So what happens in sequential engineering is that the marketing people will do their work and then they pass their ideas to the design. We have discussed this. The marketing people will survey the customers and they will carry their needs, which will become the specification of a particular product, and then they will transfer those into the design. So in design, what happens is that they will design with respect to the input from the marketing and try to develop the conceptual models and then try to test this and then pass it to the planning. So the planning department, what does is that depending upon the design, they try to plan out by using the process plans, and then they pass on the design from the planning to the manufacturing where the product is manufactured, and then it is passed to the quality where quality of the product is checked just to confirm whether the manufactured product is meeting the given specifications or not, and then it is passed to the sales and service. So here you can observe is that the information flow is across the wall. Here the information flow is across these walls, hence it is this sequential engineering is also called as across the wall engineering. Suppose the product in development has passed from this phase, this phase, this phase and this phase. Suddenly in manufacturing phase, what they say is that the product what is designed cannot be manufactured by their equipment what is available in their layouts. Then what happens? They then transfer this back to the design department, and again the design changes are taken place, and again it is sent back to the planning, and then again to the manufacturing. And then second instance, what I can say is that we may assume that the tolerance given on the product is very close or very high, because of which it is impossible for the manufacturers working on the machine to produce that component. And they again tell the design department just to reduce the tolerance that is given on the particular product. And then again this is passed to the design department, and again what happens? The design changes is done in this design department, again it is planned, sent to the planning, again to the manufacturing department. And after manufacturing, what happens is that sometimes what happens, the manufactured part may be rejected in the quality. The manufactured part, when it is passed the quality, it may get rejected. So what happens is again it is sent back to the design, again it is sent back to the design, again it is redesigned, again it is sent back to the planning, and then manufacturing, and then to quality. So sometimes, very rarely, the product may fail in service also. So that again that input is taken for the next product design, and this sequence continues. Hence it operates in a sequence, it is called as a sequential engineering. So the flow of information is always to and fro. The flow of information is always to and fro, which is resembled clearly in this picture. So that means you can see the lines of information flowing here, and again it is coming back to and fro over here. So the information is always to and fro, and the design changes is very frequent in this type of engineering called as the sequential engineering, because there is no proper coordination between the department. And also what happens is that there is a frequent redesigning that is going to happen in the sequential engineering. Sometimes what happens is that the head of each department are adamant to change. Sometimes the head of the E department are adamant to change. They think that whatever the decision they have taken is correct. So the blame game continues and thus starts conflicts between the departments. And thus this calls for an intervention of the management members to solve the issues. So what happens? Ultimately what happens because of this sequential engineering is that the material, lot of material is lost or wasted because of this old redesigning process that is taking place in the sequential engineering. And also if you consider time, a lot of time has been wasted because a lot of modification is taking place internally before it is put back into the customer. Hence, before it is put back to the customer, hence there is a time delay. From introduction of the product from the company to the customer. If this happens more frequently, then what happens is that the other company, like if you consider this as a company B, if other company will introduce this product to the customer more faster than the company A. And obviously, as it is introduced more faster with respect to company A, it will gain much popularity with the customer and also it will acquire much more market share. And because of this sequential engineering practice, there is always a time delay and a material loss, wastage or loss, and also the company loses the market share and hence there will be a less profit associated with the product. So what is an alternate for this? The alternate for this is nothing but the concurrent engineering. The alternate for this is nothing but concurrent engineering that we call it as C. But how do you say that it is an alternative to the sequential engineering? Because we'll explain this by using this diagram. So here what we see is that we have just represented the different departments, but not sequentially, but in some other fashion. So here in concurrent engineering, what happens is that there is a continuous flow of information without any interpretation. So as you know that where the cost is incurred more when the changes is done in the design phase, if the changes are done in the design phase, the cost of a product or cost in redesign is more compared to the changes when the product is manufactured, because it is directly associated with the wastage of the material. So in concurrent engineering, we can reduce wastage of material, as well as time. Because initially when the product is in the development phase or in the first phase, the engineering design will take the information from all the other departments before doing the design. So he will represent the information to all these departments, and he will take the input from all these departments, and then he will try to build on the design. And then again, what the design is built, we consider it as the first iteration. That iteration is again represented to all these departments. If any changes given by the manufacturing department, that may be with respect to the production facility they may be having, or maybe the quality that may be concerned, or maybe the tolerances that may be concerned, all these inputs will be directly given to the engineering design before the part is being manufactured, or before the part is moved from the design phase only. So those changes is incorporated, and then there will be a second iteration in the design itself, and then again it will be shared to all these departments, and again the inputs from the quality or the planning or the marketing or the service, even the service is taken. So all these inputs are taken, and then there will be iteration in the design phase itself, that is in the first phase itself. And then the product, after finalizing the design, all these neighboring departments will start their work. Suppose I'll consider this in detail, the planning. So here so if I consider the planning, we'll consider the planning only when all the design changes has been done and the design is finalized, and then each department will start their respective work with respect to the final design that is given by the engineering design department. So what happens in planning? Here also the concurrent engineering is adopted. How? Once the planning is done, the simultaneously all the relevant departments with respect to planning is called, and the final design that has been finalized for the product is discussed with each of the sub departments that is concerning to the planning. So we will tell the tool design to design with respect to the design that has been done, and he will think with respect to his perspective whether for that design the manufacturing of the tools or designing of the tools is simple or complicated here, and he will convey those ideas, and then he further conveys these ideas to here. And if that is true sense, then engineering design consider those ideas and then he will redesign. And if he says that the tool design with respect to the final design can be made without any ambiguation, then he will start manufacturing the tool for the particular design, and then the process planning is also simultaneously done with respect to all these departments that is concerned with the planning. That means here the cycle times of each process, the planning of operations or the sequential planning of the operation for that particular product is carried out, and then the material planning, what sort of material is required, what kind of material is required, in how much quantity, and what quality of the material, raw material, that all being finalized here. And then the manpower, how much workers are required and how many shifts they need to work in order to get the product manufactured. And then the workstation selection, then how many machines has to be allotted to that particular product in order to manufacture within the stipulated period of time. So these all things occur simultaneously. These all things occur simultaneously. Hence, the time delay in delivering the product to the customer is very less as compared to sequential engineering. Hence, this concurrent engineering is most widely followed compared to sequential engineering. And in concurrent engineering, what happens is that how the engineering design conveys his ideas through all these departments. He might be having certain sources that is something here is the 3D modeling. In concurrent engineering, this 3D modeling plays a very important role because it helps all this department to visualize what the engineering is trying to do with his designs. What the engineering is trying to do is design is most probably conveyed by using a 3D design, and by taking help of the 3D design also, the planner or the tool design can check what sort of tools are required to manufacture that product, and also can check the tool intervention, tool collision if you are designing a fixture to hold that product. So all this plays very important role only when there is a proper 3D model available for the particular design. Hence, in order to successfully implement the concurrent engineering, 3D modeling plays a very important role. Now, if you look at the cost that is associated in each of the phases with respect to sequential engineering and with respect to concurrent engineering, what you can notice is that because of continuous redesigns, there will be cost that will be increased in initial redesign, and again the cost will be increased in the planning because frequent changes will be taking in this design as well as planning and also in manufacturing. So the manufacturing, if the flaws are detected in the manufacturing, then that requires either a scrap or rework in sequential engineering. That scrap or rework will be more in sequential engineering because there will be a whole lot of design changes. So hence the cost associated with the sequential engineering is always on the higher side if you look at the different phases of the product in which the product passes. Now if you look at the concurrent engineering, the cost associated is always less compared to the sequential engineering because in design thing, in concurrent engineering, the cost is less as compared to the sequential engineering because the design modifications are less. As the design modifications are less, the number of times the planning changes, its process plan is also less, and the number of rejections and reworks or scrap is also less, and the number of changes in the assembly is also less, and while testing it is also less because in testing we have to test and the cost is incurred, because of which there is a cost incurred in the test but is quite less compared to the sequential engineering. So the change you can notice is this. The change what you can notice with respect to the cost factor related to the product, starting from the product development to the test and it is delivered to the customer, this is the change. So this represents a whole lot of cost. So hence by this also we can say that the concurrent engineering is best suited than the sequential engineering. And if you look at with respect to the number of design changes, this curve represents the concurrent engineering and this curve represents sequential engineering. So here what I can notice is that as in design phase, the design department interact with all these departments in the first phase itself. Hence there will be a lot of modification, inputs will be taken in the first phase itself, and hence there will be a lot of modification. You can see over here. There will be a lot of modifications what you can see over here in the first phase in the concurrent engineering, and those modifications will be less as it goes to planning, and in manufacturing and assembly and test it will be altogether close to zero because all the changes are incorporated in the design itself, and hence all the department they will give their ideas in the development phase itself. Hence there will be no changes in the planning, and hence in manufacturing also there will be a less, very negligible number of rejections, and which leads to acceptance of the product or more acceptance of the product. If you look at the sequential engineering, in design department they will not interact with the other departments, just they will pass on their ideas to the planning, and if planning rejects that ideas, and again there will be modification in the design. So here there will be modification, here also there will be modification, but here when it passes to manufacturing again it may get rejected, and here also there will be a percentage change in the modification, and in the assembly also there is a chance that these people, because they have never come in picture until the product is passed to the assembly stage. So when the product is passed into the assembly stage, then only they realize what the designer has done and whether it can be manufactured or get assembled. If they say that, they will only realize when the product is come and it has been manufactured. So when they say that it can't be rejected, and again once it is thrown back to design and again it will come, and it will be the second time they will be assembling the same product, and it will be the second time they will be manufacturing the same product. So in test also if it fails and if it is passed back to the design, there will be also the second time they will be testing the same product. So because of which there will be a lot of variations in the design, which is evident from this curve, which is evident in sequential engineering. So, if the design changes is made in the test department, then the cost incurred is very high. If the design changes are sought when it is assembled, then the cost changes are here also are very high. If the design changes are thought after the product is manufactured, then the cost associated is also very high. And if the design changes are thought when the product has reached the planning phase, then the cost associated is also high. But if the design changes are thought in the design phase itself, then the cost changes are very low. Hence, in concurrent engineering, very low cost is incurred for the design changes. But in sequential engineering, that is this curve, the cost associated for the change in design is very high. So thus it concludes that following concurrent engineering, we can not only save the time and the material, but also it results in cost saving. Next, we'll move to the next topic, that is something called as reliability. So most of you have heard this term, the reliability. I'll explain this in detail here in this class. So that means what is reliability? It means how the product is reliable to what certain period of time. So if you compare with something called as quality control, the term reliability, if you compare with the quality control with respect to quality, what I can say is that the quality control controls the quality of the product for only less period of time. That means when a product is passed to the QA department, what the QA department does is that they test the product with respect to the customer specifications, and if the manufactured product is meeting the customer specifications, they say that the quality of the product is okay. If it is not meeting the customer specifications, the quality department says that the product is not okay. So that means they will only inspect to a certain period of time. Within that time, they will judge a product whether it is okay or no. But here, when it comes to reliability in terms of quality, it monitors the quality of a product over a extended period of time. That is nothing but the service life. So that is the difference between the reliability and quality control with respect to quality. So hence, the reliability can be defined as the probability of a device or a product to perform its intended function without failure through a certain period of time. That means reliability can be defined as the probability of a product to perform its intended function without failure reliable. And then intended function. That means we can judge a reliability of a product with respect to its intended function. So I can give an example of iron. So what the function of the iron, a clothing iron set is that, or the heating iron is that, to provide a sufficient heat to the different fabrics of cloth. But that product cannot be used to maintain the temperature of the entire room, because that is not its intended function. The function of that particular heated iron box is to provide the specific heat, provide a heat to different fabrics of material or fabrics of cloth, but the function of the iron box is not to provide or to maintain a temperature of a particular room. So that is what the intended function is. Then, or you can say the intended function of this pen is to write. It is not mentioned whether it is to write fast or to write slow, but just to make an impression on the paper or give an with an ink. That is the function of this pen. What is the next is the work life. So I can say that this pen is working. If the pen is manufactured, it can't work throughout my life, isn't it? Sometimes it may stop its function. So that is called its work life. And then without failure, if I am using this pen, it may, I know that for a certain period of time it will work well, and after a certain period of time it will not work well. But within its lifetime, it has to perform its intended function without failure. That means the pen should not break until and unless the ink of the refill of this ink gets over. The pen should not break. That is what I call it as without failure. And then the environmental conditions. If I am keeping this pen, you can observe, if I am using this pen in a very humid temperature, it starts to leak. And if I am using it in very cold temperature, it may not provide the impressions on the paper. Hence, there are certain environmental conditions that are associated with the product. That is also we need to consider in defining the reliability of a product. Now we just discussed the failure pattern for any product. I just discussed the failure pattern for any product. So once the product is introduced, there will be a lot of failure, that we call it as a earlier failure period. So it goes on reducing when it comes into the phase of operating period. But also there will be a certain failure rate, but this failure rate in its operation period is almost constant. It is almost constant in its operating period. And again the failure rate increases when the product gets wear out. That is called as the wear out period. So we'll just explain this by taking an example of plastic injection molding machine. So most of you know that plastic injection molding machine are used to produce the plastic components. So wherein the plastic beads in the form of the beads, plastic material in the form of the beads are fed into the hopper, and then it is plasticized by the extruder, and then it is forced into the die to get the desired shape of the product. So basically assume that we have bought a new plastic injection molding machine. So what happens initially when we pour the plastic beads? What happens is that the components what we get, the first few components what we get from the plastic injection moldings are not of good quality, because the machine is new and there is always a temperature difference between the die, extreme end of this die, and the hopper and the extruder. So I'll just hold this itself, draw the diagram, a rough diagram. So because there will be a temperature difference between this extruder mold and the extruder, because here the plastic bead will be in certainly a bit of high temperature. When it enters into the cold mold, there will not be a proper flow of the material into this dies. So for that we need to preheat this mold. That means when the mold becomes the temperature equivalent of the plastic material, then we can get the good quality of the product. And also initially there will be a friction between the flow in the nozzle and also in the die, because of which there will be a chill or brittleness in the parts that are produced from the injection molding process, because of which the initial few parts are not of good quality. That is depicted in this initial failure period. That is, the failure period is more, the number of parts that are failed are more, and it gradually decreases as we are trying to extract more number of parts from this injection molding process. But after a certain period of time, the failure rate becomes constant. We'll get good quality of products, but sometimes there will be a failure, but they are very negligible. This may be due to the breakdown of the machine or breakdown of the die, or not proper mixing, not proper plasticizing. These are some of the problems, but those are the minor problems which will not affect the quality of product majorly. Hence, there will be defects, but those defects will be very less, and the failure rate is almost constant in this normal operating period. But once the machine becomes old, so there will be a wear out between the machines and the dies and some of the internal components of the machines, because of which we are not able to get the good quality of the products from that particular machine. So that represents this wear out period. In this wear out period, because of the wear out of the certain components of the machine, we are not going to get the good part, but instead the number of failure parts goes on increasing. So this is true for almost all products. Next, we'll discuss about the reliability terms. So I think it's already time up. We'll discuss this in the next class. In the next class, we'll discuss more about the reliability and we'll try to solve some problems with respect to the reliability. So thank you.